We're still in section 1-2. I break this down into where it says finding domain and range. Day 1 will be just finding the domain. The range should be a lot easier once you know how to find the domain. It's kind of exactly the same but different. So remember, the domain is all your x values, right? So you know when we had the little sewing machine, you put in the domain, and your range was all your output values. It's just key. Okay. When asked to find the domain of a function, they want you to give all possible x values. For an example here, they want all the numbers that you could plug into this. And it would all work. Okay? It's very helpful if you have a graphing calculator. So if everyone graphed this right now, go ahead and graph y equals 3x minus 5. Now I'm using the word function. I don't have it in function notation, but this is a function. Now, if you do not get a straight line, you're doing something wrong. Get it?
Line straight diagonal.
Not very much of anything.
An oblique line you should have. Hit zoom 6. Huh. You should get something that looks like this.
Yeah.
This is me drawing on a smartboard. They don't have a graphing interface, so this is what you should have. Now, all they're saying is they want you to find the domain. What are all the possible x values you can put? Well, what does this arrow mean?
Keeps going.
It goes forever this way, and it goes forever this way. So when you're looking for domains, all you're thinking about is the x here, okay? The y does not exist. What numbers, if any, are not included on this graph? Or put another way, is every x value at some point going to hit this line? If you draw up a value from here, does it hit it?
Yeah.
Does it hit it?
Yeah.
It will forever. That means every x value works. So you would say, you used to say this, the domain would be, remember when you had the big R? It was all reals. We don't do that anymore. We call it interval notation.
Did you want to make a sign for your farm with that on it?
Yep. Yep. Interval notation. Okay. We're gonna have to maybe sidestep. I don't know how much you remember this from last year, or if I taught it. I'm not sure. Did I?
I remember the infinities.
Negative infinity to infinity, and we use open parentheses because it did not equal. Now, what I put on the board now has nothing to do with this problem. I just want to make sure where you stand on interval notation. I had a circle here colored in, and my graph went this way forever. The interval notation would be a bracket, because it's colored in, 2, and it goes to infinity like that. Remember doing that? Okay? So, it's pretty easy when the domain is all real numbers. And most of the time, you're going to get this. Well, maybe not most of the time. Okay, so the answer to this question would be negative snowman to, people call them lazy 8s, snowman on their side, whatever you want to call them. This changes a little bit when you graph this. Now, some of you may not know how to graph this on a calculator. So, on your Y1, you're just going to hit your second square root button, wherever that is. And you should get something that looks like that. Just put x plus 3 in close parenthesis and hit graph.
Do you have any batteries?
I do have batteries, but it's quicker to do that.
All right.
Now, if you graph this correctly, you should have something that looks like that.
Yeah.
Now, this is 1 to star. This means this has a restricted domain. Okay? This is one of them. There's a couple other ones that have a restricted domain. That means you have to figure it out. Now, when you have a restricted domain, that means you have, quote, bad points. Okay? When you're talking about radicals, what happens when your radical all of a sudden becomes negative? It can't be done. So if you look at our domain, all the x values up to -3 do not work. They work here and go this way forever. And the hardest part is, can I include 3? Yes, you can. Why? I'm sorry, -3. What's -3 plus 3?
0.
What's square root of 0?
0.
That still counts. So your domain here would be bracket, because it includes -3, and it goes to infinity. Now I'll show you, once we're done graphically, I'm going to show you now how I do these when I don't want to graph them. Because I don't want to graph every one of these. It takes a long time. So I know radicals, the bad points are negatives. Okay? Those are my bad points. So I don't want any negatives. So what I do is I take the radicand, and I say x plus 3 has to be greater than or equal to 0. Right? So then I subtract 3, they all have to be greater than or equal to -3. Now I know you can do this in your head sometimes, but when it becomes a fraction, it becomes a little bit more difficult. So that's how I do radicals. And I guarantee you'll have one of those on a test or quiz, because you have to restrict your domain. So if you don't know how to do it, just take this out, set it greater than or equal to 0, and that will tell you what you have to do. Okay? Another one. What do you think that one's going to be? Without graphing it. Take a look at it and then graph it and see if you were right.
Hey, quick question. You only flip it when you divide by a negative?
Yeah, only when you divide by negative. And that's a good point I'll talk about later on the radicals. This one's thrown in there to make sure you don't just take the easy way every time. Where'd you get that? Oh yeah, that's right. I'm going to try to graph this while we're doing this. Hopefully you get that right. Does everyone get that? Okay. So what would my domain be of this? Yeah, it's all of them. It's negative infinity to infinity. Why? Why was the other one restricted and this one isn't? Jordan.
That one goes in both directions.
Yeah, but look at the equation. Better yet.
Negative.
You'll never get a negative because you're squaring it. So if you wanted to do this, x squared plus 1 greater than or equal to 0, you're going to minus this, you're going to have x squared 1 take the square root of -1. That's not working out for me, is it? Makes you kind of wonder, doesn't it? We won't do it that way. Okay? The arrow speed goes wherever. I love when a great plan goes awry. Now, going back to this one, I'm going to try to trick you. I'm going to give you a test question that I would give you on a third page if I'm trying to make you fail a question. Okay? Well, I'm telling you now, and so I won't be able to do it to you, right? What did you ask me there, Trenton, a little while ago?
Divide by a negative.
Okay? Be careful when you have one like this. I'm not sure why I'm putting a greater than sign there.
Oh, you made it so huge.
All I did is just switch them around. I want you to find the domain of this one. If you have to, you can graph it when you're done, but try to do it algebraically by looking at this. When would this go bad? Yeah. Okay, did anyone graph this on a calculator? Did it go the other direction?
Yeah.
Okay, that's because you flip-flop them. If you do it algebraically, remember, we want numbers that are greater than or equal to 0. So I subtract 2, negative x is greater than or equal to negative 2. Well, you can't have a negative variable. So then you have to flip the sign and make that. So your graph should have been, your domain would be negative infinity to 2 is what you should have had. So be careful on that one. You know, if I was really in a bad day, I'd probably throw like a 3/4 in front of it. I'm never in a bad mood anymore, so you're okay. Right, Emily? That's right. Okay, this is, again, they have no fractions there. This was right for Brandon as he's figured it out already. I want everyone to graph this first. And for you to graph this, you have to do y1, 4 divided by parenthesis, x minus 2. Even on yours, Haley, put parentheses in there. Go ahead and graph that. That's a divide sign.
Which one is?
I got that one. That's right.
That's crazy.
Oh, that was
I
terrible.
thought it was two
put
parentheses.
I guess 2 different lines.
Yeah, that's correct.
I'm good now.
Huge.
I swear that.
Your graphing calculator is a tad bit better than Brandon. What are you using? My old TI-83?
Ooh, fancy.
Oh, I don't know what I'm doing.
Is that an 83?
Yeah.
Says his doesn't have the line on
I
it.
saw Moscow's. That's gonna be harder to tell them because then you can't see.
I'd rather have the line on there. It goes right through the X coordinate. It's very helpful. Sometimes technology isn't a great thing.
Oh boy. Always. I think we're absolute values.
Okay, if you have one of the older graphing calculators, it probably looks like this, right? Let me see what you got.
Under the line.
Oh, it's under the line, okay. If you have one of the older calculators, you're going to go, Healy, be quiet. And there's this goofy line right here. I got it in the wrong spot. I'm going to fix it in a moment. Which means how your graphing calculator works, it goes left to right. So as it's working left to right, it's computing all this stuff, and it gets down here very, very, very close to what number? 2. And then it hits 2, and there's a bad problem at 2. Anybody know what the problem is at 2? It was on your last quiz yesterday. It goes undefined, so your calculator can't graph it, and then it goes past 2, like 2.000001, and says, oh no, I'm supposed to be way up here. So then it draws a line, so it has to draw, the old ones have to draw everything, and they come like this. And that line should go through what value? 2. That's its bad point. Okay. Now, if you don't have one of the older calculators, your graph is going to look like this.
It looks like. Yeah, that's what
So now you got to figure it out, and I think everyone should be able to figure this out. You do not want your denominator to equal what? 0. So at this point, I always say x minus 2 equals 0. Again, this is very easy. There's going to be sometimes quadratics down here, though. X squared plus 3x plus 2. Okay? It's going to get ugly. So I add 2 to both sides. X is 2. So in theory, I can't have it equal 2 because that's where it goes bad. So the $1 million question here is, what's the interval notation for this? It goes from here all the way to here, goes from here all the way there.
Would be
And it can include 2.
negative infinity.
Negative infinity up to, it goes to 2 because it gets very, very, very close to 2. But it cannot equal, so you put a parenthesis. If I put a bracket there, that means it includes. Then you put this symbol. What's that? Union. And then it goes from 2 to infinity. And that's how you would write that. When you're doing your homework today, your only things you have starred today will be this one and this one. If you have an equation that really doesn't have a radical or a fraction, what do you think your answer is going to be? Oh, I don't know. Okay? So just get used to seeing the domain. Now, tomorrow, maybe we might have enough time to do it today. This would be a good one. Doing the range is all the values of your y that you can have. Domain are all these x values. So a lot of lazy people like myself would put a big D. Domain. And the big R, which is me, would be the range. Now you're looking up your y values. Where do the y values start? At 1. And go to infinity. That's what we're doing Monday. The same exact thing. You're just going this way up instead of this way. Now remember, if you do a graph and your graph is only this big and your little arrow's this big, you still have to remember that they go on for infinity. Go on for infinity. I don't think that's right. So if you're